One of the few places you haven't traveled to yet is a volcano. It's an opening in the Earth's crust through which hot gases, molten rock, and other stuff get to the surface of the planet. But which one should you choose? There are different kinds of them. For example, shield volcanoes are built almost entirely of solidified lava flows, or lava domes formed by small masses of lava that are too thick to travel great distances. You can also pick a cinder cone. It's the simplest kind of volcano out there. It's built from blobs of almost solid lava that erupts from a single vent. This lava is ejected into the air with great force. Then it breaks into tiny fragments that become solid and fall back as cinders. With time, they form an oval or circular cone around the vent. Such cones rarely rise more than 1,000 feet. But what if you choose something even more impressive? How about traveling down a stratovolcano? Huge, steep-sided, and powerful. Once you've made your choice, you also decide to opt for an active volcano that is erupting at this very moment. What you're observing now is called a glowing avalanche. The volcano has just erupted a huge portion of lava, which has created a pyroclastic flow. Its temperature can reach an insane 1,300 degrees Fahrenheit. You see how this flow gets formed from rock fragments and surges down the flank of the volcano at a speed of several hundred miles per hour. Ash is raining down on Earth like grayish, powdery snow. Volcanic ash consists of tiny particles of pulverized rock, volcanic glass, and minerals. When the ash gets mixed with the water from mountain streams and rivers, raging mud flows appear. Despite how scary it all looks, you get closer. Good thing you're wearing a protective suit that can withstand any temperature. The nearer you get, the more fumaroles you spot. These are holes and cracks at the base of the volcano and in its slopes. They emit huge clouds of steam and volcanic gases, carbon dioxide and sulfur dioxide. Some of the cracks are so large you can probably squeeze through and sneak a peek inside the volcano. But you have a different destination, the crater. On your way there, you spot a strange conical structure on the side of the volcano. It looks like a horn growing on the main cone. It must be a secondary cone, also known as a parasitic cone. Such cones form around secondary vents that reach the surface of large volcanoes. In this case, an eruption can occur not only through the main vent at the top of the volcano, but also through these additional vents. In any case, that's not where you're heading. Soon, you reach the crater. It's a massive circular basin. When you go to its edge and look inside, you see it's also very deep. The lava vent, which is where you need to go, is at the bottom of the crater. But even before jumping into the vent, you spot some strange tubes hiding under the lava flow. Those are lava tubes, natural passages through which fresh liquid lava travels beneath the surface of the lava flow. You decide to make a detour and follow one of the tunnels. It's the main lava tube. You also spot several smaller tubes. They supply lava to one or more lava flows. If the volcano wasn't erupting at the moment, the lava would drain downslope from this tube system. The passages would have lava marks on the walls, a flat floor, and lava stalactites hanging from the ceiling. But even now, there's some empty space above the flowing lava. That's because it has eroded downward, making the tube deeper. But right now, you need to get back. You take the next turn and get back to the crater. You wait till the volcano spews another portion of boiling lava and dive into the volcano's throat. It's the entrance of the volcano. Lava and volcanic ash get ejected from here. The volcano's throat is wide, and you easily travel deeper down. The lava around you glows bright red and orange. That's because when it first bursts to the surface, its temperature can reach 2,200 degrees Fahrenheit. That's hot enough to melt iron. You move down the volcano's main vent. It's a weak point in our planet's crust. There, scorching hot magma manages to escape from its chamber and reach the surface. While going deeper and deeper into the vent, you notice sills. Sometimes, lava intrudes between the crack in the crust, pools there, and crystallizes. This creates deposits of ash and solidified lava. That's what sills are. Pretty soon, you reach a magma chamber. It's a large pool of molten rock. The one you're in at the moment is quite shallow. That's because it's not the main one. After traveling several more miles down through the vent, you get to another huge magma chamber. It supplies the small one beneath the base of the volcano. The main magma chamber lies in Earth's crust, which stretches from 3 to 44 miles deep. The molten rock there remains under extreme pressure, and the temperatures inside are incredibly high. With time, the rock surrounding the magma chamber starts to break and fracture. This creates outlets for the magma, and since it's made of a much less dense material than the surrounding rock, the magma begins to seep through the cracks to the surface. From the main chamber, it rises to the upper one. Then it makes its way to the surface in a powerful eruption. You explore the magma chamber and then decide to go even deeper than that, to the place from where all that molten rock gets into the magma chamber. You're moving through the crust. The volcano is located on land. That's why your trip takes longer than it would if you were traveling through the oceanic crust. It's only 3 to 6 miles wide. But the continental crust is much thicker. It can be 28 miles thick in some places. As you're going through the crust, you can't but notice its light color. That's because it consists mostly of granite. If you were going through the oceanic crust, the material surrounding you would be dark or nearly black because it has a different composition. The deeper you go, the hotter it becomes. Sure, the temperature here isn't as high as in the magma chamber, but still, at the boundary with the mantle, your thermometer shows 750 degrees Fahrenheit. At a depth of about 20 miles, you reach the boundary between the crust and the Earth's upper mantle. There, the pressure reaches a mind-boggling 10,000 atmospheres. That's where magma comes from. You could finish your journey and get back to the surface, but your curiosity gets the better of you. You decide to go deeper, all the way to the center of the Earth. The next layer on your way is the mantle. It makes up 2/3 of the Earth's mass and 84% of our planet's volume. It's 1,800 miles thick. The rock closer to the inner part of the mantle is semi-solid, like caramel candy. The upper part of the mantle, as well as the crust, is broken into massive pieces. They look like a colossal jigsaw puzzle. Those are tectonic plates. They drift at a speed of 1 to 2 inches per year. You're moving through the upper mantle and feel the temperatures rising up to 1,600 degrees Fahrenheit. Near the boundary with the core, the temperature is already as high as 7,000 degrees Fahrenheit. The pressure in the lower mantle reaches 240,000 atmospheres. You'd feel the same pressure if 3,300 elephants made a tower on your head. At a depth of about 1,800 miles, you see the boundary between the mantle and the outer core. The insides of the planet around you are heated up to 9,000 degrees Fahrenheit. Such temperature is high enough to keep the outer core liquid. The pressure there is almost 2 million atmospheres, but it's not enough to make the iron that the core is made of solid again. The outer core is 1,500 miles thick. It churns in massive turbulent currents and generates a magnetic field. In the outer core, Earth's magnetic field is 50 times more powerful than at the surface. You are now more than 3,000 miles underground, and you've reached the inner core. It's a solid metal sphere, around 1,500 miles across. The inner core is immensely dense and spins faster than the rest of the planet. The temperature there is as high as on the surface of the sun, 9,800 degrees Fahrenheit. And the pressure inside the inner core is 3 million times greater than on the surface. It took about 500 million years for the inner core to form, which means it's younger than some parts of the crust.
Hey, we landed on the moon. We sailed around the world. Romeo met Juliet. Hey, it's hard to imagine that there are creatures out there who saw it all happen. Immortal animals. Well, almost. Glass sponges are weird little creatures that sit in one place for thousands of years. From their favorite spot under the sea, they witnessed the first Europeans crossing over to the Americas. They can live up to 15,000 years. And what's even cooler is that they can control their aging process, speed it up or slow it down. They have a glass-like exoskeleton for protection. Lobsters can grow back a limb if they lose it, and they're basically immortal. They produce an unlimited number of enzymes that keeps their DNA young forever. And they just keep on growing. That means they outgrow their own shells. They have to shed their exoskeleton every now and then and upgrade to a bigger one. The largest lobster ever caught was 44 pounds off the coast of Nova Scotia. Scientists think this large lobster was around 100 years old. It was around when Edison invented the phonograph. This next creature is a mix between a jellyfish and a tree branch. Each end of the hydra has a ringed foot, and it spends its days chilling by lakes and rivers. Its tentacles grab onto tasty snacks that swim past it. So, what's the secret to its immortality? That's something everyone wants to know. The hydra has the ability to renew its stem cells. Scientists have been trying to do that for years. They can actually slow down their aging process. Now, these little sea creatures are red sea urchins. They sit on seaweed in shallow waters and are immortal. Well, we haven't been studying them long enough to know for sure, but scientists say they only grow in size, not in age. What? Well, they sort of stay like little baby urchins, but grow in size. Adult, baby urchin, okay. These little babies can reach around 100 years old, even 200. The slowest on the list? The giant tortoise. It can reach 200 years old, and one of the oldest is Jonathan. He's technically the oldest crawling land animal. He was born in 1832 and lives it up on a remote island called St. Helena. Jonathan's been through a lot. He's seen the very first American skyscraper, the Eiffel Tower. Oh yeah, he's also lived through every single World Series, starting when he was 71 years old. Now he can't see too well and he's lost his sense of smell, but he's still going strong. Back to the oceans and the Greenland shark. It's been known to be the longest living vertebrate and can live more than 400 years. Swimming around for that long in the deep, dark, cold ocean means these sharks are tough. They're able to withstand insane water pressure. Sharks are one of the only creatures today that haven't been affected too much by evolution. Many sharks have been around since the dinosaurs and haven't changed much. Scientists found out that they grow around a half an inch per year. So, with a little bit of quick math, they can easily find out the age of these tough sharks. Imagine seeing a shark that's older than the USA. This next creature is probably the most durable, indestructible, and cutest on the list. It's called a tardigrade, but scientists nickname it water bear because I guess it looks like one. But it's not exactly bear size. It has 8 legs and hands with a strange little nose. And these bizarre microscopic creatures are indestructible. They're known to live in the most extreme places on the planet. They're fine with temperatures as high as 300 and as low as minus 330. Volcanoes, frozen desert nights, they can even handle radiation and massive amounts of pressure in the deepest parts of the ocean. They can even survive the vacuum in space. No tiny little spacesuit or anything. Yeah, that would be cute enough. So far, they've survived 10 days on the outside of a spaceship, but they could probably do longer. Tardigrades might be able to outlive humans if there's some sort of worldwide catastrophe. Microscopic organisms in charge of the planet. Wonder what that would look like. Whether it's all the volcanoes erupting at once, or another ice age, or even another pesky asteroid. Tardigrades probably wouldn't even notice. Scientists are studying them to see if they can help us with some next-level biotech. Now, just for fun, here's the mayfly. This poor little insect doesn't even make it past 24 hours on average. Females and males can make it to a whopping 2 days old. Talk about living in the moment. These little flies grow in swarms and are known to have one of the shortest lifespans of any creature. But as a species, well, they've been around for hundreds of millions of years. Jellyfish have discovered the fountain of youth, and surprise, surprise, it's been inside them all along. Not inspirational poster style, but literally, it's always been inside them. Jellyfish are able to reverse their aging process whenever they want. Imagine you're swimming along and then you think to yourself, gee, I kinda want to be 8 again. And poof, there you are. Who wouldn't want to go back to being 8? That's how jellyfish stay young and live stress-free. These brainless and boneless creatures can turn the clock back anytime they want, as long as no one bothers them. They're super chill, just floating in whatever direction the current takes them. Like, go with the flow? This creature looks like something right out of a sci-fi movie, and you could say it has sort of alien features. The giant weta outweighs a mouse and is considered one of the biggest insects out there. You find these big bugs in New Zealand. While jellyfish can reverse their aging process, some members of the weta family can come back to life. Talk about superpowers. If they get completely frozen, they start to make special proteins that stop their organs from getting ruined. After whatever amount of time they're frozen, they can be thawed out and brought back to life, like nothing ever happened. In fact, the giant weta has ears on its knees in its front legs. And because it can resurrect, it's also called the zombie bug. Planaria are flatworms that are unique. Apart from being practically immortal, they're the ultimate regeneration machines for lost body parts. If you take one of them and divide its body into 10 parts, you'll end up with 10 new planaria. You keep dividing them up, they'll keep multiplying, even though they're usually less than an inch long. Imagine if we could figure out how to do that. Would that be a way for us to live forever? Or would we end up with a totally crazy world with copies of everyone walking around? How about the world's fastest relay team, 4 identical Usain Bolts? Now, clams have been around for a really long time. Scientists have discovered that they can live up to 400 years old. These little shelled creatures are the ones that create those shiny little pearls everyone loves. A clam will go into action mode when a parasite gets inside. The clam tries to cover the parasite with a bunch of special chemicals, the same ones it uses to make the inside of its shell. That's when the magic starts to happen. When these chemicals harden up, they make a shiny, glossy pearl. The more chemicals, the bigger the pearl. Now, this long, slippery-looking creature lives deep in the caves of Europe. Olm can live up to be 100 years old. It spends its days hunting for little insects, snails, and crabs with its tiny front arms and wriggling snake-like body. Its skin is so pale that some locals even call it the human fish. Hey, wait a minute. The olm is almost blind, but it can still detect light. It just mostly does it through its skin. Like other blind animals, it has a supercharged sense of hearing and smell. It gets its distinct look from those little red gills around its neck. Now, there are things about nature that you know for sure, or don't you? Let's check how much you know about the incredible world we live in. How many of the 14 points will you guess? Let us know. The Great Pyramid of Giza was built when mammoths still roamed the earth. Myth or fact? It's actually a fact. The most famous pyramid in the world had been constructed about 500 years before woolly mammoths went extinct, approximately 4,000 years ago. Their last known habitat was the cold and deserted Wrangel Island in the Arctic Sea, which might not have been as cold then as it is today. There are more trees on Earth than stars in the Milky Way. Is it myth or fact? It's a fact. Scientists used to believe there were about 4 billion trees on our planet, but more recent studies have shown that there are over 3 trillion of them, making it 420 trees per person. As for the stars in our galaxy, there are only about 100 billion, which is 30 times fewer than the trees on Earth alone. The trees you see are all individual ones, myth or fact? This is false. In fact, 90% of the trees on Earth are interconnected by mycelium filaments. They send warning signals when in danger and exchange nutrients through them. It's kind of like the underground internet. Also, there are organisms like Pando, for example, which is the largest single living being on the planet. It looks like a dense forest of quaking aspens. In fact, it's basically a single giant tree, with its roots being interconnected underground. We drink the same water dinosaurs used to drink hundreds of millions of years ago. Myth or fact? Actually, it is. Only a small portion of the water on our planet has evaporated for good. The rest of it is constantly renewed. So, mammoths, dinosaurs, and whatever came before them billions of years ago drank and swam in the same water we see today. Not to mention what else they did in the water. Unfortunately, the water doesn't keep information about those ancient creatures for us to find out more about them. Lightning never strikes the same place twice. Are you willing to bet on that? Myth or fact? If you aren't, good for you. Lightning may strike the very same spot as many times as it wants. It might seem random, but the electrical discharge from the sky is pulled toward the tallest objects in the thunderstorm area. Also, the material this object is made of matters too. It's by no chance that lightning rods on buildings are mostly made of copper and aluminum alloys. These metals are some of the most conductive materials, so they pull lightning very efficiently. All deserts are hot. Now, this one's easy, right? Myth or fact? If you guessed it's a myth, then right you are. Deserts are qualified not for their temperature, but for the presence or absence of growth and life in them. The most well-known desert is the Sahara, of course, and it is indeed very hot. The actual largest desert in the world is Antarctica, which is almost twice the size of the Sahara Desert. And you wouldn't call it even lukewarm. It's a polar desert, and there are several others on our planet. For example, Greenland. There's enough gold underground to cover the entire planet in a thick layer. Would you believe that? Well, you should, because it's true. Since 1950, humanity has mined nearly 200,000 tons of gold. If we made a cube out of all this metal, it would be 70 feet high and wide. Recent data from scientists confirm that there are huge reserves of gold in the Earth's core. The metal is enough to cover the whole planet, and people might have gold up to their knees. The problem is, we just can't mine it from there. Hey, I don't mind if you don't. The Moon and Mars are better mapped than the Earth's oceans. Now, this can't be true, can it? Actually, it can. We have a detailed map of the Moon and Mars, although we're still discovering surprises on their surfaces, granted. Still, over 80% of the Earth's oceans are unmapped and unexplored. We can't study the oceans properly because of pressure, cold, and lack of light underneath billions of tons of water. The lava is always red. What other color can it be, right? Myth or fact? Myth. Usually lava is really red or orange because it's basically molten rock from the deep bowels of our planet. But there's one volcano in Indonesia whose lava is blue and luminescent. Only at night though. During the day, it looks normal. No mystery about it, just tons of sulfuric gas. This volcano also has the largest acidic crater lake in the world. The water there is so turquoise, you want to jump in immediately, but you probably guessed you should never do that. The fire on that volcano is also blue, the largest blue fire in the world, rising up to 16 feet high. Ever seen a gas stove burning? Here, the principle is basically the same. You can see a rainbow at night, too. Is it myth or a fact? It's true, and there's even a name for this phenomenon, a moonbow. Also called a lunar rainbow, this event occurs extremely rarely. It's similar to a regular rainbow, except when it appears on a clear moony night after a rain shower. There's a thing called a fire rainbow, myth or fact. You bet! It's a beautiful phenomenon when the clouds in the sky are painted all the colors of the rainbow, looking like a fiery, multicolored cascade. It only occurs when the conditions are right, and those are very specific. It's close to the equator, the weather is clear, there are feather-like clouds in the sky, the sun is higher than 58 degrees above the horizon. Such clouds are made of ice crystals. When the sun's rays hit them, the particles refract the light and create a rainbow. Wow! There are rainbow trees. Myth or fact? If I made you doubt this, I'm glad, because this one is not photoshopped. This is the rainbow eucalyptus, and their bark may literally have all the rainbow colors. These eucalyptuses shed their bark at different times each year. Every time the old section goes off, the tree first reveals bright green bark that was hiding underneath, and then it may turn any color. There's a whole set of hues: orange, maroon, blue, even purple. Stones can move on their own. Myth or fact? Well, you'd be right to believe me. There's a desert plain in California where rocks move around of their own will. Once this plain used to be the bottom of a lake, but then it dried out and became an arid wasteland. Sometimes rains fall here, flooding the entire valley. When night comes, the temperature drops and the water is covered with a thin layer of ice. When it gets warmer again, the ice breaks into segments and the wind pushes them around the place. Some of these ice shards take small rocks with them. When the ice melts for good and the water evaporates, the only thing that remains are trails left by the rocks, as if they'd moved on their own. Mud puddles can move around. Myth or fact? In fact, a single mud puddle in the world also travels as it wants, and nobody still knows why. It moves at a pace of about 20 feet per year, and it seems to have started its journey near the San Andreas Fault in California. People have tried to stop its march but couldn't. So far, this creeping natural disaster isn't showing any signs of stopping on its own either. So, there's your pesky, problematic puddle to ponder.